Okay, a very good morning to all. And we have today to start with what is called as weather forecasting. Now, an interesting part about weather forecasting, or rather, before we go to weather forecasting, uh, why is this the last topic as far as your syllabus is concerned? Of course, we need to do one more topic, and I will be doing that after weather forecasting as such. But if you see from the earlier topic, we have done the layers of the atmosphere, and then we came to the lowest layer of the atmosphere, that's the troposphere. As far as the troposphere is concerned, we spoke about the differentiation in insolation at various levels, horizontally and vertically, and that led to the variation in temperature, and we saw the various reasons why these change and so on and so forth. In between we had the heat budget, etc. also, okay, that tends to maintain the temperature of the surface of the earth as such. Okay, the differential heating of the temperature that we have been differential heating of the surface that has led to variation in temperatures at different locations. There could be, say, global factors affecting that. There could be local factors affecting that. That led to formation of pressure systems, and the adjustments between these pressure systems are known as wind systems. Now, wind systems again are global, seasonal, and locational, or you would say local winds as such, okay, which was seen through what is understood as the global or the atmospheric circulation as such. Having done that, then we went into a bit more detailing as far as a few processes are concerned. The most important process as far as this the atmosphere is concerned, okay, which is more visible one that we had uh, referred to, is basically the availability of water or water vapor in the atmosphere around us. And in this whole process, we saw how there is a transfer of energy when moisture changes from one phase to the other, from solid to liquid and liquid to gas, and from gas back to liquid and solid. And then we saw how much of energy is being released or used up, which is called as say latent heat of either evaporation or condensation as such. Okay, we spoke about the availability of say the whole sense of water vapor in in the atmosphere around us, which is called as humidity. And we spoke about the various measures which we use to measure humidity, and how saturation point is significantly important for us, and how that relates to relative humidity as such. Condensation leads to formation of water vapor or precipitation of water vapor at various levels. We saw how condensation near the surface is actually called as mist or fog, and say precipitation is in the form of dew, etc., dew and frost, for example. And then the same condensation, when it happens at a height, how we call them as clouds, and how different clouds are arranged, and characteristics of various clouds as such. Formation of clouds is dependent on a few factors, and these were, say, the uh, condensation point and adiabatic heating, the environmental lapse rate, the wet adiabatic lapse rate, the dry adiabatic lapse rate, which led us to the three various processes that we normally find in the atmosphere, and that is basically to say absolute stability, absolute instability, and conditional instability as such. Okay, which yield us rain as such. Okay, that brought us to the next. Say in between, of course, we spoke about evaporation and condensation also. Finally, we came down to air masses, characters of air masses. We classified air masses according to their geographical location, according to their physical location, according to their temperatures, and according to their stability and instability. And we saw the processes which happen or which are generated out of, say, two air masses confronting each other, which was uh, discussed in detail as far as the the temperate cyclones were concerned. We saw the whole process of how a cold front and a warm front march into each other. Okay, interestingly, they don't march into each other head on, but you'll see that they deflect, and this deflection leads to formation of fronting. You have a cold front, and you have an advancing cold front on one side, and you have an advancing warm front on the other side, and how the development of say various fronts from cold and warm eventually to start of an occlusion front, and finally an absolutely established occluded front. And when occlusion gets over, that's the stage wherein the temperate cyclone dissipates as well as such. In between, we saw a few wind systems called as the gradient wind, and we saw the the gradient wind and the geostrophic wind. And of course, example of this was seen in the process of understanding what are called as the jet streams as such. Okay, so we have covered a lot of things. Okay, at every point of time we were made to remember and realize what is the use of all that we are doing as far as climatology is concerned. Okay, you'll see that climate is one of the most dynamic elements of say all the spheres around us. Okay, you'll see that climate changes within minutes, I would say. As far as water surfaces are concerned, this may take a few days, while as far as land is concerned, we saw in plate tectonics that it would take hundreds of years. So one of the most dynamic spheres around us is, of course, the atmosphere. And this brings about a lot of change, and we need to be ready for this particular change. And being ready for this particular change involves one basic thing that you're seeing in front of you, and that is weather forecasting. Unless and until you see and you have the weather forecasted for you, it would be very difficult for this changing dynamic weather that changes so very regularly and so very fast around us to adapt to it, to adjust to it as such. So once having done all the basic processes in climatology, it becomes equally important that we understand how weather is forecasted, what is the requirement as far as weather forecasting is concerned, why is weather forecasted, what is the importance of all these studies as far as climatology is concerned. Now, what you see on your screen is, you'll see that gentleman is actually putting forth what he's referring to as weekend forecast. Weekend meaning Friday, Saturday, Sunday. Okay, today is Saturday, and you'll see that we are on a weekend as such. Normally, you'll see that in Western countries, Saturday and Sunday being holidays, okay, people move out on Fridays. As a consequence, you'll see that any news channel finds it important to let its viewers know what is the weather going to be like for the next 2 3 days as such, so that they can plan their holidays accordingly as such. Whenever something comes up for discussion on the latest media, obviously we need to realize the importance of that particular thing as such, and that you'll see that weather takes a significant segment of any news channel, means weather is equally important as such. Not only because of the dynamism of it, it's also important basically because of its sheer importance with regards its impact as is concerned as such. Why do we study weather? Okay, weather forecasting is one. To study, to forecast weather, we have to actually study this weather. Okay, why do we study weather, and eventually why do we study keep a data of climate? Okay, we know that when we study the geological past of the earth and the future predictions as such, we see that we have been experiencing climate change throughout, and this climate change is experienced due to various reasons. One of the reasons we have seen in the earliest part of the syllabus when we were discussing about the Milankovitch cycles, etc., etc. Of late, we have been also referring to the fact that human beings also have been responsible for this climate change. The use of fossil fuels and say other aspects that man has been performing regularly for the last few thousand years, okay, have been somewhat also responsible for climate change. Having said this, climate change is a natural phenomena also, and as a consequence, we have to put these two together and try to see how climate has changed through the past, and how the present climate is actually say suitable for our species as such. When we bring this whole element of climate to weather, and weather to a local location as such, Okay, we come to this second point of the need of trying to understand why we need to forecast weather as such. Okay, nowadays we always read in newspapers that extreme events are on a rise as such. Heavy rains and thunderstorms and abnormal weather systems, etc., are more frequently being tagged these days as such. Okay, now extreme events obviously will have extreme effects. Okay, to and these extreme events, not that they have not been happening in the past as such, but you'll see that these extreme events are seen through what are also referred to as changing patterns as such. Okay, the frequency. I was speaking to a scientist the other day, and they say the group together were actually studying the correlationship between the tropical storms in the Bay of Bengal and the Arabian Sea. And the observations are that the number of tropical storms in the Arabian Sea are on the rise as such. Now, what are the reasons? There could be many reasons as such. And this is again something that we need to record and monitor and interpret as well as such. At a very personal level, you'll see that this impact, the impact of these climatic or weather parameters around us, make an impact on life, and they make an impact on food resources, if we are to speak on an absolute personal level as such. Life, in the sense, impact on the life would mean that extreme events would cause destruction of life and property also as such. You'll see that rain and water is something which is very important as far as food resource generations are concerned. At the same time, extreme events like floods and extreme events like frost and other aspects will damage the food crop, which will affect the economy of food as well as such. So all put together, we are required to understand this whole process of what the weather is, how we expand the weather into climate, how we study climate, how the climate is changing, and what should be done as far as this whole aspect is concerned. Of course, though we study about this independently, let me again remind you that all the three spheres, the lithosphere, the hydrosphere, and the atmosphere, are very much intricate, and they are related to each other. And a change in one is obviously going to affect the output at some other end as well. So most of the reasons why we should be studying the weather around us, why we should be actually tracking it down and making a note of all of this together. Uh, One more thing as to why and how there is a rise as far as importance of weather is concerned. You'll see that these are the various emojis that we nowadays find on, say, our mobile screens and apps and such. Okay, you'll see that whenever we look into a weather app as such, you'll see many of these. Okay, though they are not quantitative, that means they are not showing the exact amount of sunshine or cloud cover or rainfall, etc. They are very much qualitative. Okay, which means that, say for example, this is going to be heavy rain, this is going to be rain and thunderstorm as such, this could be hail, and this could be sleet as such. Okay, this is snowflakes. Okay, this is lightning. Okay, so they may not be. This is of course sunrise. You may not know the time, but this is sunrise. This is sunset as such. Okay, this means a possibility of rain, or you may require that, and so on and so forth as such. So they are so much qualitative. Obviously, they don't. They are not quantitative as such. And we need to move towards the quantification of these very elements as such. When we speak about these quantifications, I would say, I don't know how many of you all, but most of you all may have done what are called as weather reports, interpretation of weather reports as such. And you'll see that weather map, as it is called, the weather map. This is an India daily weather map, which is at the first one. There are two every day. This is the 8:30 morning one as such. And this is way back, Monday, 1st of June, 1992. Now, what is the difference between a present weather map and this? We'll see that nowadays we have direct images, but this is something which is hand drawn. Okay, and this is transmitted on the on map as such. Everything is hand drawn as such, and now, of course, we are into a lot of digitization as such. And these maps nowadays will involve this is something that we saw yesterday also: the cold front, the warm front, the stationary front, the occluded front, a trough. Okay, you'll see that you find a trough here. This is a trough. Trough means a low pressure zone as such. Okay, then this is a ridge, a squall line, a dry line, and a tropical wave as such. Okay, then you'll see that you have weather map symbols as such. Now they start from say the wind speed you can see here to the cloud cover here. Okay, how much cloud is there, then the pressure tendency to rise or to drop as such. Cloud symbols, what are the various types of symbols? You'll see uh, this is a more elaborate explanation of that as such. Okay, so I'll just name a few. Okay, you will see that the tallest of the clouds, the cirrus clouds here. Okay, so something like a hook are cirrus clouds. Okay, this is cirrus, this is cirrus, this is cirrus, this is cirrus. Okay, something that starts with these two bumps, and then you have this line joining here, and this is something like a broken specks as such. These double bump symbols are related to the altocumulus clouds. So cirrus is hook-like, and this is altocumulus is a bump-like thing as such. And you'll see that the clouds which grow are called as cumulus as well as such. Then you have the precipitation symbols and such. And of course, we have thunderstorms, etc. Okay, now you'll see that nowadays, okay, you'll see that present weather symbols in the sense that if you are to track down what is happening right now, immediately, the present condition, you have these present symbols. You'll see that many of these are from here. Say, for example, as far as precipitation is concerned, you'll find it here, and so on and so forth. You may not have at any point of time gone into the details of this, but because it is not required. And then you have wind speeds. These are a few parameters which are used as far as measuring weather conditions are concerned. At such very gentle wind, slow wind, less than 1 knots. By the way, remember that wind is measured in knots per hour. It's not miles or kilometers as such. Okay, so if it is going to be 1 to 2, then you'll see that this is 1 0, and you straighten this up. Okay, then you have 3 to 7, and then you'll see 8 to 12, and then 13 to 7. So it's a split of 4 kilometers, 4 knots. Sorry, 4 knots at every level, and you'll see that it keeps on adding these sticks every increase, half a stick, full stick, half a stick, full stick, till the time you reach 50. And at 50 you're going to have a triangle sort of a thing. Okay, then 53 to 57 again is a small stick here, and then it grows, and 100 will of course be 50 plus 52 triangles, and so on and so forth. So this is how we tend to understand these symbols as such. Nowadays, let me tell you, they are not much in use. They are more of academic importance, but as students of climatology, and since we have a topic called as weather forecasting, it becomes equally important that though something, it's not absolutely obsolete, it's not absolutely outdated, and that's why it forms a part of our study as well. In fact, I would like to go into the details of the present weather symbols, because there is one reason to that. Okay, and what is that reason? You'll see that many of these symbols are actually related to each other. So just having around 99 symbols does not need not scare you. Okay, each of the symbol has some value and some importance, and there are some repetitions as such. Okay, say for example, these say these S here, 30 onwards, let us say, yes, 30 onwards, 30, 31, 32, 33, 34, 35, all have this S. Now what does this S mean? Okay, this is a storm, S for storm. This is a dust storm. Okay, and has decreased in the past hour. Okay, no change during the past hour. Decrease in the sense, you'll see this is an arrow in the direction which possibly it is blowing, and that you have this vertical. There are logic behind this every of these symbols as such. Okay, that it has decreased in the past hour means it has gone down. No decrease will be this much. Okay, has begun and has increased. So you'll see that towards, you put the same line towards the left side, it has just begun as such. Okay, during decrease during the past hour, number 33 is again here. Okay, and then severe storm or sandstorm has no change in the past during the past hour, is this hollow arrow as such. What is the difference between uh, the earlier S and this? Let us see, severe or moderate. Okay, this is severe, slight or moderate. Sorry, it was not severe, it is slight or moderate. Severe means an empty and a thicker arrow, you can see. Okay, so from 32 to 33, it has gone severe. If it has decreased in the past hour, you have a vertical line. If it has just begun, it have a vertical line towards the left side. And if it is no change, you don't have vertical lines as such. So these are interesting ways in which we can actually use and interpret these as well. Let us look into another set of, say, common ones as such. You'll see this is a comma like a thing, single comma, double comma, comma above each other, three commas in a straight line, four commas, and you have one more here as such. We'll just keep it for some time. Then you have a dot, double dot, vertical dots, triangle of dots, straight line of three dots and four dots as such. You have an asterisk here. Okay, asterisk sign, and two, and then vertical ones, and then a triangle of them, and then that's why we need to understand the logic. Okay, initially I would have shown this to you. You must have said, my god, how 99 symbols, how do I remember it? Now I can show you that literally 50 to 55, 60 to 65, 70 to 75, 80 to 85, 90 to 95. Okay, 6, 1, 2, 3, 4, 5, 6. 30 symbols are going to have some logic as such. Okay, single comma is drizzle, not freezing. Okay, intermittent. This is a drizzle. Okay, this is just a very weak rainfall. Then this is rain. This is not freezing as such. Okay, these are snowflakes. Okay, this is rain shower slight. Okay, sure, I'll just adjust this way. Okay, showers or of all, or what was this, rain or rain snow or thunder mode. Okay, let's keep this aside a bit. Now double comma is drizzle continuous. Okay, this is stopping, intermittent and coming is stopping. Okay, two commas is obviously going to be a drizzle, but it is going to be continuous. Two dots is going to be rain, it's going to be continuous. Two flakes is going to be continuous fall of snowflakes as such. Okay, then we move to one above the other, drizzle, not freezing, intermittent. Drizzle, not freezing, intermittent, moderate at the time of observation. Okay, this is slight, this is moderate. So it has increased from slight to continuous to moderate. Okay, you'll see that the same thing, rain, moderate, snowflakes, moderate at the time of observation. Okay, then a triangle of these three commas. Okay, drizzle, not freezing, continuous, moderate at the time of observation. Drizzle, not freezing, continuous. Okay, this is continuous. The drizzle is continuous here. Okay, the rain tends to get continuous and the snowfall tends to get continuous as such. Okay, when they are above each other, okay, heavy, it has now gone heavy at the time of observation. This is heavy at the time of observation. So increase in the number of symbols is obviously showing you, there's one logic that we can understand from this, that it is showing an increase in the pattern of that particular weather phenomena as such. Okay, four commas is going to be heavy at the time of observation. Okay, okay, much heavy. Okay, this is much heavier and this is much heavier as such. When speaking about this arrow here, okay, this is in relation to thunderstorms. Okay, you'll see thunderstorm, and again that say vertical bar, but now this is with like a bracket here as such. Vertical bar is at the time of observation, sorry, during the past hour. Okay, this is again thunderstorm. Okay, and now it is going to be a bit heavier. Okay, this is going to be a thunderstorm with snow. Okay, heavy snow here as such. Okay, in the last hour, and so on and so forth. Thunderstorm or slight moderate hail, and so on and so forth. So once again, you'll see here a continuation of what we had seen earlier: drizzle, freezing, slight, rain, freezing, slight. Okay, so till here it was not freezing. See, not freezing, not freezing, not freezing, not freezing, not freezing. The moment you have this S shape, it's going to be slightly freezing. Okay, slightly freezing. Okay, and then with or without fog, ice needles have come up here as such. Drizzle, freezing, moderate. Freezing but moderate, it has increased the intensity here again as such. Okay, and drizzle and rain, moderate or heavy. Rain or drizzle, moderate or heavy. Ice pellets is shows you this particular symbol as such. And I would want you all to go into the details of others as such. Okay, you'll see that the origin of these will be found here. I purposely did not start with this. Okay, you'll see that this is lightning visible, no thunder heard. Okay, this is just lightning, no thunder heard as such. Okay, thunder starts with this. Okay, this is here, and they have say used a half T, T for thunder, thunder heard but no precipitation. And then you'll see that here, okay, this is thunder heard, and of course you have precipitation also. So single line. Okay, say for example, we can say just sorry. Now this is okay. I'll use it this way. What is this? This is nothing but lightning. Okay, you add this to it. This is going to be thunderstorm. Okay, thunder. And if you're going to add this is going to be rainfall. If you are going to add this is going to be for the past hour, and so on and so forth. So this is a progressive type of understanding as far as all these are concerned as such. Okay. As I said, that nowadays most of this is technology oriented, and you have sensors, etc. And this has reduced the whole exercise of actually putting it down by an observer. You need to have a trained observer who's going to sit down, and in spite a person could have been a trained observer, there could be a chance that an individual may actually miss out on a few things because there are so many things happening at a particular point of time. So we require technology, and technology has been regularly being updated, and of course it's a very dynamic thing. It's continuously being updated, and all these updated info tends to nowadays bring in a lot of say a lot of advanced research as far as weather forecasting is concerned. When we speak about weather forecasting, we need to understand weather. What are the basic elements of weather as such? As I said, the start of weather, okay, is with air temperature, the heat that is available in the form of insolation. This insolation, how much of it is absorbed, how much of it is going to be transmitted, leads to intensifying the temperature, the intensity of the heat in the air, and that is what is air temperature. When this air temperature, high or low, will yield you the amount of pressure that air particles will actually create on the surface, and that is called as atmospheric pressure or air pressure at a particular location. As such, we have seen that higher temperatures will be say high temperatures will be low pressure, and low temperatures obviously will be high pressure. Okay, in the pressure, I would skip off the third for a moment, and then I will go to this, because adjustment of pressure is yielded by movement of air particles horizontally, and that is going to be wind. If this wind is going to carry material in it, it is going to affect visibility. If it is going to carry water vapor in it, okay, that water vapor will initially be condensing into form clouds, and these clouds will then be giving you precipitation as such. And this formation of clouds and the amount of precipitation obviously is going to be dependent on humidity. So these are the basic elements which are required as far as studying the weather is concerned as such. Now, just to go into it batch by batch, you'll see that atmospheric pressure will be the weight of air on the earth. You have high pressure and low pressure, and of course, you have synoptic mapping. We're coming to that. Clouds, basically three types. Cirrus are the tallest ones. Okay, stratus clouds are layered clouds, and cumulus are those which build vertically as such. Humidity, they have just given you two water vapor in the air, relative humidity. Remember, we have done various ways of measuring humidity as a part of our syllabus as yet. Okay, temperatures will bring in heat index and wind chill as such, precipitation of various forms, in the various form, right from rain to snow to fog to sleet to mist to hail. Okay, you could have a long list of these as such. So this is something that you have to keep in mind when we are actually going to go into the detailing of say forecasting. Okay, before we go to forecast is something that you're going to project. Okay, and you project something only when you have some data with you. Okay, and how is that data collected as such? Okay, this is an output of all this. Okay, nowadays, of course, as I said, technology has gone up to such an extent that nowadays we have so many of these apps. Okay, and you could just go on say Google's Play Store and search for weather apps, and you'll have various of these weather apps. Actually, in fact, we are using one of them, the weather and radar app, and of course I have asked you all to perform a small assignment on it as well. But to reach this level of having technology behind you and giving you direct outputs, okay, we need to understand the whole scenario. Okay, you'll see that the photograph in front of you shows clouds. These clouds are of different shades in the background, and of course, you have the blue sky in the foreground as such. Okay, you have a different shade to the sky towards the say the deep end of of this particular photograph as such. So, a particular this particular photograph shows you various types of clouds, the shades of the color of the sky, and we need to understand all these things before we get into the right position of forecasting various things for us. Okay. Uh, when we speak about weather forecasting, what we spoke about temperature as a factor or a parameter is basically dependent on radiation from the sun and of course radiation from the atmosphere as such. At the same time, you'll see that radiation from the surface of the earth as such. The adjustment, if you remember the heat budget, we spoke about evaporation and its role in the heat exchange as such. So repeatedly I keep telling students that it is the heat energy which is very important as far as climate study is concerned. Okay, when you're going to add water into this, okay, this will transform into clouds, and you'll see that it is these clouds will lead to either say rain, or it would lead to formation of or precipitation in the form of snow as well, snow and rain as such. And that's very interesting. These are very interesting parts of weather forecasting as such. Friction is another important aspect. If you remember, we spoke about this in say the geospatial geostrophic winds and gradient winds, and of course we spoke made a mention of this in jet streams as well. Okay, the friction is going to be more if the wind is going to flow more near the surface. It's going to be less if it's going to be in the upper layers as such. When we speak about weather forecasting, we use basic principles of geography in weather forecasting. This weather forecasting would be temporal. This weather forecasting could be spatial as such. Okay, now what do we mean by temporal? It's time based. Okay, you'll see that on a broad scale we start with actually you may have noticed this, that when we actually are watching our weather on a radar weather and radar app as such, you'll see that they give you hourly changes also. So in fact, I could add here early, but I will start with daily forecasting of weather. Okay, then you have weekly forecasting of weather, monthly forecasting of weather, seasonal. Okay, that means say a particular season, say for example monsoon. How is this monsoon going to be? Or an annual form of weather forecasting as such. Okay, besides that you have long term forecasting, and then you have the study of climates, which actually is not forecasting, but for the purpose of forecasting you need to have some studies of paleoclimates, that is climates in the past as well. Every element of the society is going to be, in fact I would say every element on the surface of this planet is going to be say benefited out of this. Okay? At least human beings would be able to understand this. Okay, when I say daily weather, okay, as I said that it becomes important for people who will be moving out and would be watching out for any extreme event that could happen. Okay, so daily. Okay, if you're planning to move from one region to the other, from one place to the other, and which is at a distant, then weekly weather forecast are going to be important. Monthly and seasonal obviously are going to be important as far as economic practices. Say, for example, agriculture is concerned, you'll see that monthly and seasonal forecasts could be very, very important as far as as far as agriculture as an economic activity is concerned as well. Annual, okay, if you're going to draw a budget on a certain thing, obviously you'll see that annual forecasts tend to get important. You'll see that as far as monsoonal forecasts are concerned, it's divided into all the five things. You start with annual, and then you have some seasonal changes in that, you have some monthly corrections in that, and of course you have weekly and daily predictions or forecasting as such. Long term paleo and paleoclimatic studies are actually related to research levels, okay? But indirectly they also do have an impact on individuals, so that also, or these also need to be an important part of weather forecasting as such. This is as far as time based forecasting is concerned. As far as spatial or space based forecasting is concerned, you could speak about weather forecasting at a very micro level, as such a small area. Okay, it could be 1 square kilometer, it could be 10 square kilometers, and so on and so forth. Okay, when you increase it to a few hundred square kilometers, you would be actually forecasting weather for a macro region as such. If you are going to do it for the whole country, say for example a country like India, then you are at a much larger scale. That's a national scale as well. Continental scale, okay, you'll see that the continent of Africa, the continent of North and South America, the continent of Asia as well, say the weather for a whole continent would be that. And of course you would have global weather also. Global weather is a complex of all these, but then you require this in connection to long term uh, predictions as such, or forecasts, or the study of paleoclimates also. Obviously this is an endless list. You can go into many combinations. Okay, daily global weather, daily say weekly global weather, okay, monthly continental weather, seasonal national weather, and so on and so forth. Okay, so you can come out with n number of combinations when it comes to forecasting. And why do we come up with n number of combinations as far as forecasting is concerned? Is basically because every purpose is going to serve someone. Say for example, for a country, planning for a country, okay, you would require a different combination. For traffic police in a particular area, you would require a different combination. Okay, for aviation industry, you would require someone else. Okay, and so some other set of parameters, and so on and so forth. So it's a very intricate thing, it's a very complex thing, and we are trying to say yield out the best of all of these results as such. So this is actually weather forecasting and its subdivisions on temporal and spatial scale as well. Okay, you'll see that interestingly weather tends to be involved in entertainment industry also. Okay, I've just got a few of these from the net as such. Okay, right from many a times we do understand that rain tends to get in a lot of emotion out of individuals as such. And here you can see that this is one of the first of the Barsat series movies as such. We have had many movies titled Barsat, and after that as well as such. Okay, then you have Kadvi Hawa. Now, this is actually how what we mean into a political. It could mean into a political sense also. Okay, and see what is. I'll read it out. I don't think you are able to read this. A blind old man and a young bank loan recovery agent, ironically, both coming from two extreme weather conditions, have zero contribution to the global climate change. Fight for their survival. Okay, this is what is Kadvi Hawa as such, and of course you have the weatherman, of Nicholas Cage. And of course, I could bring in a lot many of them, many songs you could say in Hindi and Marathi. All of these are based on, and in fact, in the Indian entertainment industry, weather tends to play a very important role, not only as far as the shooting is concerned, the context is concerned, the relevance is concerned. Okay, you'll see that is it's very very interesting to note that aspect of weather also as such, not directly related to weather forecasting, but that is how it is. And you have our very own IMD, the Weather Forecasting Services. 14th of January was the 147th foundation day of the IMD as such. So in another 3 years, say 2025, they would be celebrating their 150 years of establishment as such. As I said, that when we forecast weathers, it is actually of importance for various elements of the society as such, right from the general population to a fisherman who would go fishing as such, someone who's going to go mountaineering, or someone who is interested in flood forecasting, particularly someone from the government officials would be interested for that. Agriculture, farmer to the planner, everybody related to agriculture would be important, would be say getting their information from the IMD weather forecasting services as such. And then you have the aviation and the civil and the military. Okay, shipping of course requires this as well. Navy, the mercantile part of shipping and the navy part of shipping. Community projects would require that as such. Port officials would require that. Offshore drilling rigs, okay, you need to know the weather. Okay, and of course defense services will have their uh, eyes set on how these IMD personnel are going to forecast weather, or these weather services provided by then as such. Of late, we have these weather forecasting solutions. Okay, you have in India, you have many in India and abroad. Of course, initially we had government agencies looking into weather forecasting solutions, but nowadays you'll see that even private agencies are involved, and they are earning a lot of revenue out of providing accurate weather conditions and eventually climate and the data for that also. So that's weather forecasting solutions at a private level for you. What exactly weather forecast and solutions will mean, we will take it up tomorrow. We'll see some mythological aspects also, but that's all for today, at least I would say. And I will stop here and come back to some discussion. If you're having some questions for me, you could please ask me those questions as to all that we have done today. As such, if you have any observations on your side, because weather is not something that is only taught many a times, though at say a naive level, at an amateur level, we do experience various weather phenomena, and accordingly, you could have had questions relating to that. So, if you have any questions, you could surely ask me those questions as well. And if you don't have any questions, then first of all, I will actually stop the recording for the day.